Hey guys, so in this video we're going to learn about the three-dimensional shapes of molecules. So we've learned how to draw Lewis structures, and that makes all of the molecules look flat. But we live in a three-dimensional world, so the molecules don't actually look flat the way we draw them. So we're going to learn a couple of the different shapes that they have and how you can tell what shape a molecule has. So there is a theory that we use to help us figure out shapes, and it's called VSEPR theory. This is actually an acronym though. It stands for valence, shell, electron, pair, repulsion. So VSEPR, repulsion. And that's a theory. And the idea here is we know that electrons repel each other because they have negative charges. So electrons in bonds and lone pairs are going to arrange themselves to be as far away from each other as possible. And that's how we can figure out exactly how these molecules are going to be shaped. So it's a pretty good system, and it works pretty well. So what we're going to do is there's basically 5 different shapes that you need to know. And we're going to give you an example of each one. So we're going to draw a molecule, and then we're going to figure out how many bonding groups it has. That just means how many atoms are bonded to the center atom. How many lone pairs it has. Remember, those are sets of 2 electrons that are not in bonds. And we only care about lone pairs on the center atom. A lot of this will become a lot more clear when we draw these pictures. Then I'm going to tell you what that shape is called and what the bond angle is for that particular shape. All right, so you can take notes with me and draw these molecules along with me. So first one we're going to do is methane. This is natural gas. It's a carbon with 4 hydrogens bonded to it. So anytime you have 4 bonding groups, see I have 4 hydrogens bonded to my center atom, and 0 lone pairs on the center atom. You notice there's no lone pairs on the carbon. That is a shape called tetrahedral. And the angle between these bonds, you might think this is a 90-degree angle, but this is actually a 3-dimensional shape. So the angle is actually 109.5. And let me show you what this actually looks like in 3 dimensions. So it looks like this. So you can see it's kind of like a tripod with a thing sticking up at the top, like this. Or you can think of it as a right side up V and an upside down V, arranged at like 90 degrees to each other. So that's what tetrahedral looks like, and this angle is not 90, but 109.5. And for you guys, if we've got 4 bonds, that's going to be the shape. That's our only 4-bond molecule we're going to look at. If you get more advanced, there are others, but for us, we're just looking at this. Okay, so 3 bonds now. We're going to draw a carbon, an oxygen double bonded to it, and 2 more oxygens off to the bottom. And this is actually the carbonate ion, so I'm going to put brackets around it and put a -2 charge, because it has a -2 charge. Now notice there are 3 atoms bonded to the center one, so that means 3 bonding groups. There are a bunch of lone pairs on the outside atoms, but none on the center. So 0 on the center atom. If that is the case, it is a shape that we call trigonal. Remember, tri means 3, so that makes sense. Planar. So think in geometry, a plane is like a flat surface. So this is actually a flat molecule. It basically looks the way it looks on paper. It's just like a Y shape. And the angles are 120 degrees. And that should make sense because 3 times 120 is 360. And if you add all those angles up together, you've got a full circle there. Okay, let's do another molecule with 3 bonds. But this one has a lone pair at the top. So it's got 3 bonding groups, 1 lone pair. This one is called trigonal pyramidal or pyramidal, depending on how you want to pronounce it. And it has an angle of 109.5. So if you have 3 bonds, there's 2 options here. If you do not have a lone pair on the center atom, it's trigonal planar. If you do, it's trigonal pyramidal. And those are the only two options. Trigonal pyramidal has a bond angle of 109.5 again, so it's kind of like a tripod. It's a lot like tetrahedral, just without the atoms sticking up at the top. The lone pair is up here instead. So this one's three-dimensional, this one's flat. All right, let's talk about molecules with two bonds now, and then we'll be done. So carbon with two oxygens bonded to it, this is carbon dioxide. It's got two bonding groups and 0 lone pairs. If that happens, it is a shape that we call linear, and the angle is 180 degrees, which is a straight line. So that's pretty easy, linear to straight line. Now, if we have lone pairs, like sulfur dioxide does, on the center atom, it's going to be a different shape. So we've got two bonding groups, because two oxygens, and one lone pair. That shape is called bent. And the angle here is going to be 120 degrees. So it's kind of like trigonal planar, but without the atom at the top here. So that's bent, and then there's one more I want to draw. This is water, one of the most common molecules. Got two atoms bonded to the center and two lone pairs. Now this shape is also called bent, but the difference between this molecule and this molecule is because there's two lone pairs here, this angle is going to be a little narrower, so it's actually going to be 109.5 again. So that is valence shell electron pair repulsion theory. So you need to know these 5 shapes: bent, linear, trigonal pyramidal, and trigonal planar, and tetrahedral. And it may seem like a lot, but once you practice a little bit, it's pretty easy to distinguish these. Again, we've got 4 bonds, it's tetrahedral. If you've got 3, it's either trigonal planar or trigonal pyramidal. And then if you've got 2, it's either linear or bent. And the bent can have 2 different angles. And that's it.